Step 4. Developing an MEP model in ArchiCAD. In this step, we will develop the cable tray network of the project based on 2D documentation received from the electrical engineer. We will use the MEP, Mechanical, Electrical, and Plumbing, Modeler, a powerful built-in tool in ArchiCAD. Architectural practices and architectural departments of architecture engineering firms using ArchiCAD can use MEP Modeler to create, edit, or import 3D MEP networks, ductwork, plumbing, piping, and cable trays, and coordinate them with ArchiCAD Virtual Building. If you do not have an MEP Modeler license, you will not be able to do these steps. In this case, just follow the steps in the movie player, or register at myarchicad.com and download the fully functional student or 30-day trial version. Double-click to activate the 941 Developing MEP Model preset view from the Navigator view map. This view shows the second floor of the right wing. We will use this part of the building to demonstrate the MEP Modeler and will only model a few elements of the entire cable tray network. Make sure the E13 second floor cable tray drawing is activated as a trace reference below the floor plan. We will use this worksheet as a reference level to create the cable tray model. Before we start work, we need to set up the libraries and work environment for the MEP Modeler. Activate the File, Libraries and Objects, Library Manager command to open the Library Manager dialog. Click the Add button on top of the dialog. Browse and select the MEP Library 14 folder from the ArchiCAD 14 program folder on your hard drive. Click the Choose button, and then click the Done button in the Library Manager dialog to load the MEP-related objects to the project. Please note that the GRAPHISOFT MEP Modeler ships with the rich MEP-specific object library. This library contains specially configured MEP elements that include smart connection points for automatic connection during routing of MEP systems. Upon installation of the MEP Modeler, relevant standard ArchiCAD objects, like basins, toilets, and so on, will be extended with smart connection points as well as specific MEP-related parameters. Open the Work Environment dialog. Activate the Options, Work Environment command. Select the Work Environment profiles at the top of the left window. This activates the Profile Options page on the right side with the available stored profiles. Note that the MEP profile was added to the list after the GRAPHISOFT MEP Modeler application was installed. Choose the MEP Profile 14 stored profile and click the Apply Schemes of Profile button. This brings up the Apply Profile dialog. Click Apply in this dialog and click OK to leave the Work Environment dialog. Notice the ductwork, pipework, and cabling MEP tool groups have been activated in the toolbox. The ductwork group in the toolbox provides a set of tools to model mechanical elements. Tools in the pipework group are used to create plumbing elements. And finally, the tools in the cabling group were developed to model electrical elements. All three MEP toolbox groups are similar. There are dedicated tools to model straights and bends, and designers can also insert transitions, junctions, or terminals to the MEP network, as well as place inline elements or equipment. MEP elements are parametric for easy configuration of custom dimensions. Open the window, Toolbars, MEP Toolbar. The MEP toolbar contains the most frequently used MEP commands and functions. Click the MEP Systems button in the toolbar, the first button from the left, to open the MEP System dialog. MEP systems represent a group of MEP elements which belong together. MEP systems can have a uniform color code to ease the identification of elements belonging to the system. Element schedules and quantity takeoffs can be created faster as well. Let's create a new system for the cable tray network. Click the New button. Enter Cable Tray for the new MEP system name and click OK. Check the Cable Tray checkbox in the Use With field and uncheck the Ductwork and Pipework checkboxes. Choose the 25% fill type. From the pen sets, select or enter 46 for contour pen, 46 for fill pattern pen, and -1 for background pen. -1 will display the window background for the background of the fill. For center line type, choose dot and dashed, and select the 46 pen for the centerline pen. Finally, set the system material to 09 Paint 18 and then click OK in the MEP System dialog. Double-click to activate the 942 Routing Cable Tray preset view in the Navigator view map. Let's display the MEP Routing palette. To do this, click the second icon from the left in the MEP toolbar. Please note that the routing function of the MEP modeler enables us to create connected MEP elements with a series of mouse clicks, thereby greatly improving productivity and increasing efficiency in daily design and modeling work. Here you can define the MEP system you wish to create, decide about routing options, and construction methods. These options can also be changed during a routing operation if necessary. Select cabling from the drop-down list at the top of the dialog. Enter 1 foot for the width and 2.5 inches for the height. Click the right arrow button in the middle of the dialog and select the current story option from the list. Select the right bottom alignment point and enter 9 feet 8 inches for the level of the cable tray. Choose the previously created cable tray from the drop-down list below the MEP System field. Click the Routing option. Click the right arrow in the top right corner of the appearing panel and select Mitered Type. And then select the M-Lite CBTR layer. Click the Start Routing button to start creating the cabling. Click labels 1.1 and 1.2. We have placed the first cable tray element. Keep the routing active, and let's change the width of the tray. Move your cursor back to the MEP routing palette and enter 1 foot 4 inches for the width. Notice that the width of the tray increased on the screen at the same time. We can now continue the routing. Click on labels 1.3 and 1.4. While still keeping the routing active, move your mouse to the right until you can see label 1.5 and then click on it. To finish the first part of the cable tray, click on label 1.5 again. Double-click to activate the 943 Placing T connection. You can see a T connection next to the door. Let's place a T connection type of cable tray. Double-click the Cable Carrier T tool below the Cabling MEP Toolbox group to open its Settings dialog. The Cable Carrier T Default Settings dialog appears. Go to the MEP Custom Settings panel. select the mitered geometry button at the bottom of the General Settings field. Enter 1 foot 4 inches for the D branch width field. Select M-Light CBRT layer from the drop-down list at the bottom of the dialog. You can keep all other settings of the T because these properties will automatically come from the placed cable tray element when we connect to it. Reposition the anchor point to the end of the left branch in the preview window, and then click OK. Click Label 2.1 to place the T element. Move the appearing eye cursor up and click on the screen. As you can see, the connection elements have been placed according to the trace level, exactly above the 2D cable tray underlay. Using the trace level, you can continue developing the entire cable tray network in the right wing by yourself, or you can just activate the next preset view to see the completed model. Close the MEP Routing palette. Then activate the 944 cable tray preset view to see the entire cable tray network in the second floor of the right wing. Switch to the 945 cable tray 3D preset view to see what the cable trays look like in 3D. Any conventional 2D CAD drawings, such as DWG or DXF, can be imported to ArchiCAD for the basis of the MEP model. ArchiCAD users can easily model, visualize, and edit 3D MEP building networks, ductworks, pipeworks, and cable trays for 3D coordination or visualization.